tiny galaxies lit up the early universe. New data confirms for decades. Scientists have puzzled over what reionized the universe after its dark ages. New findings from the Hubble and James Webb Space Telescopes suggest that the answer lies not with massive galaxies or quasars, but with countless small dwarf galaxies. These faint cosmic powerhouses collectively emitted enough energy to clear the primordial fog of neutral hydrogen, allowing light to travel freely across the cosmos. The cosmic dawn and the fog of hydrogen shortly after the Big Bang, the universe was filled with a dense, hot plasma. As it cooled, protons and electrons combined into neutral hydrogen, creating a cosmic fog that blocked light. To turn on the universe, something had to reionize this gas, stripping electrons from hydrogen atoms and allowing photons to escape. For years, astronomers assumed this job was done by large galaxies undergoing intense star formation or powerful black holes. However, new observations challenge this assumption. Dwarf galaxies, unexpectedly bright and international research team, led by astrophysicist Hakeem Atek, analyzed data from a distant galaxy cluster called Able 2744. This cluster acts as a gravitational lens, magnifying the light from background objects, including faint dwarf galaxies from the early universe. Using the James Webb Space Telescope, JWST, the team discovered these dwarf galaxies were far brighter than expected. They outnumber larger galaxies by a factor of 100 to 1, and collectively produce 4 times the ionizing radiation previously attributed to larger structures. Despite their tiny size, these low-mass galaxies are prolific producers of energetic radiation, and their abundance during this period is so substantial that their collective influence can transform the entire state of the universe. Hakeem Atek this finding is significant because it redefines our understanding of cosmic reionization. Instead of needing a few powerful sources, the universe was lit up by a vast population of small, energetic galaxies. Why this matters: understanding how the universe was reionized is crucial to understanding its evolution. It marks the transition from a dark, opaque state to the bright, transparent cosmos we observe today. The discovery that dwarf galaxies played such a dominant role forces a reassessment of cosmological models and the early formation of galaxies. The team acknowledges that the current findings are based on a single patch of sky. Further studies of other gravitationally lensed regions are needed to confirm if this sample is representative of the wider early universe. The future of research, the JWST has opened a new era in cosmology, allowing scientists to peer deeper into the universe's past than ever before. Themia Nandiyakara of Swinburne University of Technology emphasizes that this discovery raises more questions than answers, setting the stage for further exploration. The findings were published in Nature and represent a pivotal step toward resolving one of the fundamental mysteries of cosmic history. The fog is finally lifting, revealing a universe far more complex than previously imagined.